Welcome, guys. In this video, we're going to be taking a look at a review of some of the factoring strategies we learned earlier in the year as a means to kind of apply it to some of the quadratic equations and quadratic applications we're moving into soon in class. So if you remember in the beginning of the year, we started with multiplying binomials. We used the box method, or we used some FOIL type distribution like this, and we were able to derive a trinomial in simplest form. And eventually we looked at that in reverse. We said, if you're given a polynomial like what we have on the right, how can you kind of break it apart into those two bubbles without knowing what you started with? And if you look at this relationship left to right, you start to see a pattern here, whereas the 6 and the -4, if we add those two numbers together, we consistently get that b value in the middle. So that was adding them together. We get that number there. If we do 6 plus -4, we get 2. And it should follow, hey, if I multiply those two numbers together, 6 times -4, I get -24, which also appears in our final answer. Okay, so that's kind of like multiplying, we can think of as a product. And this is where we got our sum product rule from. When we're given a trinomial and we want to break it apart into two binomials, we're really trying to find two numbers that have a sum of b and a product of c, the constant on the end, and b is the coefficient of x. Okay, so if we take a look on the bottom here at a more specific example, we have x squared minus 10x plus 16. So right away, however you want to label this or however you want to identify a little reminder of what's what here, it is called the sum product rule, so that order is important. We can't just kind of flip-flop these as we wish. We can make a little chart like this. This is referred to as like a diamond method, just organizing your numbers a little bit here. Sum and product. And the real trick with this sometimes is kind of the searching or the process of finding the two numbers. Okay, there is some guess and check involved. Remember, it's always a good idea to start by looking at your product. Okay, there are going to be a lot of things that add to a certain number, whereas multiplying, there are very few options. Okay, let's make a wrong guess to start. First of all, if they have a negative sum and a positive product, the only case where that could happen is if both terms are negative. Okay, if we're multiplying two positive numbers together, that's the only other way to get a positive number. There's no way to get a negative sum. So we could use that at least to our advantage. And let's try something like -4 and -4. Because if we multiply those two together, we do get positive 16. So that checks out. But up top, when we add those two together, we get close. We get -8. We're looking for -10. So just going through the motions of showing you how, you might not hit your first guess all the time, but you can work through it. If we guess another number here, -8 and -2, we'll eventually see that it checks out on both ends. Okay, it multiplies to the 16, and they correctly add -8 minus 2 is -10. So now we set up our two binomials, or two bubbles. We put x as the first term in each of them. That's kind of like a forgotten step sometimes. Not that you forget to do it, but you kind of forget why you do it. That's representing when you FOIL this, when you multiply this, the x times the x is going to give you the x squared up front. The numbers really just deal with this part of it. And it was -8 and -2. And like we related to earlier, you can always check that you did this correctly by working backwards, by FOILing, by multiplying out, and seeing if you derive exactly what you started with. Okay, so these are the easier examples. They may be a little rusty. We haven't done them since earlier on in the year, but these were the easier examples where A was 1. In other words, there was nothing here. There was nothing out front. But if you remember, we eventually got into examples where A is greater than 1. And this involved a little bit more conscious thought. A little bit more steps were involved here. Because now all of a sudden we can't just say x and x in our bubble. We have to put additional terms. So in this case, I eventually want to factor this. Okay, the question would say like factor or write as a product of two binomials, something like that. So what I'm going to do first, the sum still stays the same. So I'm still searching for 15. But my product is not just 7 on the bottom, which it would be on that last slide that we did. The product here, remember, is a product of A and C. This is where we got the name eyeglass from, because when you kind of draw that line, it looks like a pair of glasses. Basically, you have to compensate for the fact that there's a 2 up front. When you're eventually putting these in bubbles and multiplying them out, that 2 is going to have an impact. That's why we multiply it out. So now 14 and 15, this is relatively easy. Something that multiplies to 14 and adds to 15. Again, there's only very few things that multiply to 14. 7 and 2, no. 14 and 1, yeah. 14 times 1 is 14. 14 plus 1 is 15. Now, unfortunately, this doesn't end it. We're not done right here. If we continued it the way we did it earlier this year, I'm going to show you some additional ways about thinking about this with another example. We would write it like this. So all we did so far, we still have the same expression. Look what we started with, and look what I just wrote in purple there. Okay, what changed? Instead of 15x, I now have 14x plus 1x, which we could all agree is still 15x's. By doing it this way, it should work out, whereas if we factor these first two terms and factor the second set of terms here, this is called factoring by grouping. The brackets aren't necessary, I'm just putting them there more or less to show you what I'm focusing on in terms of groups. The numbers are going to work out a certain way, so I'm going to pull out a GCF on the left, would be 2x. They're going to work out in such a way where we get something nice that happens. Pulling out a 2x leaves x plus 7 behind. And on the right, there is no GCF, but there is always a GCF of 1, so I could pull that out. And now if you remember, we call this, or you should notice that we have a common bubble. Okay, each of these sets now has an x plus 7, so we could think about factoring that out. So I'm pulling out an x plus 7 from each set, left and right again. And then we had what we called like our leftover bubble, what was hanging around after the fact, that 2x plus 1. And this would obviously give us our final answer. Okay, like I said, this was one way of looking at it, breaking up B, so breaking up 15 into 14 and 1. You can't just break up 15 into anything you want. It does have to follow that sum product rule, because then it will work out nicely where you always get that common bubble and your kind of leftover bubble, if you will. Okay, so now I do want to show you guys an additional strategy, an additional way of thinking about these tougher examples. And again, this is all going to tie back into solving quadratics, a skill that's required for solving them in future lessons, knowing how to factor. Okay, so we'll do another one where a is greater than 1. So once again, we got a sum of 4 here. The strategy still requires you doing like a little sum product setup. So we got a sum 4. Our product here is going to be 3 times negative 15 or negative 45. If you're not a big fan of this diamond way of thinking about it, I know sometimes in class we've done something like this, a little table. Some of you guys just literally write out the word sum and then the number. Anything like that's fine. It's all about what works for you, what you like visually to see. But this chart, this diamond chart, is usually pretty popular. So now with this one, we're looking at a negative and a positive because it's a negative product. We're looking for a product of 45 or negative 45 and a sum of 4. Okay, so the larger number here is going to be positive because we have a positive sum. So I'm going to go with positive 9. And you could probably guess the second number here is 5, and the 5 should be the negative 1. Sometimes with these negative positive examples, people put the sign in the wrong spot. Just always double check that it is adding up to positive 4. Because sometimes you run over the numbers quick. You just do like negative 9 and 5, and you're thinking 4, but you do want to make sure you have your signs correct. So, what we're going to do now, this method is a little bit weird, but it's definitely one of those ones that makes things easier, but it's a little weird to think about why certain things work. So right away, we're actually going to jump into 2 bubbles. Okay. Since there was a 3x squared in front of each one, each bubble is going to get a 3x. Similarly, if there was a 5x in front, 5x squared, we would put a 5x in each bubble. I know it doesn't make sense because if we FOIL that, we'd get 9x squared, but you'll see where this is going. The two numbers we just found, it doesn't matter where we put them, since each bubble gets a 3x. We're just going to write them in. Okay, and now this is usually referred to, if you want to look up additional videos, I've seen it called like a garbage method. Basically, you're just going to pull out GCFs, anything that you see in either bubble. Garbage and dump, I think they call it, if you want to look at some other videos that other teachers have posted. So on the right, I don't see anything, so that bubble is going to be good. But on the left, I see 3x plus 9. Should be pretty obvious that there's a GCF of 3 out. GCF of 3 in there. So pull it out and just kind of, like, so it's called a garbage method. You're kind of just getting rid of it. Hey, there's a GCF of 3. So if I divide both of those guys by 3, let's just lose the 3. And it becomes this. And that would actually just be our final answer. So you see, this way is actually a lot quicker. It is a little bit on the abstract side because some people, I probably shouldn't put this equal sign here. I know first time I've seen this done a few times, I always question like how we rationalize writing this, because you're really not writing an equivalent expression, but it does work. It's a cool little trick. Sometimes both bubbles have a GCF and you're pulling out multiple things and you're arriving at a final answer that works. So it is a nifty little trick. If you're not sure how we went from here to here, once again, I'm pulling out a 3. So I got that. And then we're just kind of literally forgetting about it. We're dumping it. Okay. So new strategy, I think it makes things a little bit easier, especially for people that have trouble with the strategy we went over on the last slide, but something that definitely works. So a little quick review, probably not on the quick side, but a review of all the factoring strategies we've done earlier this year, specifically with trinomials. We know we have our dots method. That's not really anything that extraordinarily difficult. I would say these are the more difficult strategies what this video went over. Dots and some of the other GCF techniques are a little bit on the easier side. So these would definitely help with quadratics, which we're going to cover throughout the next few weeks. So hopefully you found this helpful. Thank you guys for watching. If you have any questions, please let me know or comment in this video and I'll do my best to get back to you. Thank you.